We are still in chapter 1. We're now in section 3. And we're going to just continue building this mathematical toolkit for math tools that you need to be able to do higher maths like calculus. So the next topics that we're going to cover, we're going to start with the idea of increasing, decreasing, and constant. And I'll show you what I'm talking about here. So what you have, what I have graphed here is the average fuel efficiency, which is basically just miles per gallon. And now, of course, this is U.S. passenger cars, so new passenger cars. And we have miles per gallon graphed over some time interval, right? So we could say that in 1955, on average, new passenger cars were getting just over 15 miles per gallon. And now this is not recent, but as of 2009, they're getting closer to 35 miles per gallon. The only point of this graph is to show you what you would expect. Of course, that you would see decreases and increases over a time period. Now, the questions that we're going to ask are going to look something like this. We might give a graph and say, state the intervals of time where the graph was decreasing. So you can see that we have miles per gallon is decreasing all the way up through the 70s, right? And that's so from here to here, your fuel efficiency is decreasing. And then once we get to here, we start getting increases in fuel efficiency. So what we're interested in is listing those intervals where something's increasing, decreasing, or constant. Now, to a mathematician, some things are extremely intuitive, right? All of us can look at this and say, yes, it's increasing. But mathematicians have a very formal way of being able to say, a graph is increasing or decreasing or constant. I will read one of them to you, but we're not going to dwell on it. Just because it's fairly self-explanatory what we're looking for. So we would say that a function is increasing on an open interval, right? So in order to say that this graph is increasing over some interval, if f of x sub 1 is less than f of x sub 2, right? So here's f of x sub 1, and here's f of x sub 2. For all x sub 1 less than x sub 2. So I won't dwell there, but the main takeaway for now is, let me just make sure you understand really quickly. So we have to all be looking at this graph with the same point of reference. So we're always looking at a graph from left to right. Because if you could imagine, somebody could say, well, hey, somebody might look at this graph and say that, we would be walking up the mountain. And somebody might look at this graph and say, well, you could be walking down the mountain. But if we're always looking at the graph from the left to the right, then we would say that this is increasing. So that's an important takeaway. But nevertheless, let's just jump in. So I'm producing two graphs for you. We'll start with A. And what do they want? We want to state the intervals on which the given function is increasing, decreasing, or constant. All right. So again, extremely important that we're looking from left to right. All right, here we go. So I'm going to start from the left. So it looks like it's decreasing all the way until we get to this point right here. Agreed? So it's decreasing. All right, so all of this is decreasing. All right, at this, we have a turning point and we start to increase. And then we have another point and we start to decrease. All right, so it's our job right now to capture those intervals. So let's start with decreasing. So we're coming from negative infinity and we're proceeding all the way till we get to this point right here. So let me go ahead and write that. So from negative infinity all the way until we get to, do you agree with me, at when x is 0, that's when we start to turn. So negative infinity all the way to 0. Why did I write that under increasing? I meant to write that under decreasing. Okay, and then now from 0, we start to increase, and we increase until we get to this particular point right here. So let's see if you agree with me that from here, from 0 to, it looks to be 2, from 0 to 2, we're increasing. So from 0 to 2, we are increasing. All right, and as soon as we get to 2, we start to decrease. And we just keep decreasing. So back to decreasing from 2 until positive infinity. Now, this point, this graph was never constant. It was always either going up or going down. So this graph was never constant. Okay, so easy enough, except let me go ahead and show you, let me tell you where students mess up. Ready? So let me just make a statement. If I'm asking you about increasing, decreasing, or constant, if I'm asking you about the intervals, ready? Here it is. You are only listing x values. I'll say this one more time because the mistakes are happen enough to where I'm gonna make sure you get this point. So ready? Let me make a mistake. If I ask a student, if I give a student this graph and I say, what is the interval where this graph is increasing? A student might make this mistake. They might say it's increasing from 0 to 4, and that is wrong. Because I didn't ask how much did it increase. If I asked how much did it increase, then yes, it increased from 0 to 4. But I asked what is the interval that it was increasing, and that is the x values. So we're always listing x values. I hope that makes sense. Ready? Let's go to the part B. So just taking a look at the graph, it looks like we're coming from negative infinity. Looks like we're just constant, all the way till we get to 0. Now, when we get to 0, we start to increase. It does, so it doesn't appear that this graph ever decreases. So not applicable. Let's go ahead and list constant. So this graph is going to be constant from negative infinity all the way till we get to 0. Right? So from negative infinity all the way till we get to 0. We are constant. All right, and now let's list the interval where we are increasing. So starting at 0, and as you go this way, the graph is increasing the whole way. So it's increasing from 0 to positive infinity. Okay, so I hope that makes sense. I know it's a relatively easy concept. Where is it going up or down? But it is something that you need to be able to just be aware of. You're only listing the intervals, the x value intervals. All right, next topic. So let's before I read any definitions to you, let me actually let me kind of add some context here. So what I have graphed here is let's pretend that this is the average salary of someone over their lifetime, right? So let's pretend like this is you or someone you know. So I have time listed in years on the x-axis, and I have salary listed in dollars on the y-axis. So it appears that, let's say you or someone you know started working somewhere around, say, 15, 16, and they were making, I don't know, that's a little over $10,000. And now, as time goes by, their salary starts to increase. Now, notice something happened right here. So, will you agree with me that if this is you or someone you know, that at this age right here, however old they were right here, they were making the most money they ever made in their life up to that point. But it appears that their salary started to decrease a little bit, right? Maybe they decided to go back to school. And so they took a little bit of a cut in their salary so they could maybe gain some more skills. And the goal was, once I gain some more skills, now my salary can increase even more. Now, at this point right here, let's you and I agree that this is, at this age, this person was making the most money they ever made in their life. Now let's give this some mathematical terminology. So the language that we're going to use is what we call an absolute maximum or a relative maximum. Let's start with the easy one. Let's start with the absolute maximum. So like I was just saying, you and I think we can agree that at this point right here, this was the absolute maximum salary that this person had ever made in their life. Now, what do we mean by relative maximum? Well, the relative maximums, remember this little point right here? So, as we said, that this individual, relatively speaking, when they were this age, they were making the most money that they had ever made in their life up to this point, right? In other words, let's see if you agree with this statement. If you're standing here, if you take one step to the right or one step to the left, you would be at a salary less than what you would be if you just stayed where you are. Agreed? So that's what we mean by a relative maximum, where it's basically it is a maximum relative to its surroundings. Okay, well, what about a relative minimum? Well, let's see if we can find a relative minimum. Well, what about right here? Do you see how this is this turning point where if you were to go a little bit to the left or a little bit to the right, you would be making more money than what you're making if you stayed where you are, right? So that's what we mean when we say relative minimum. So just it's a minimum relative to its surroundings. I hope that makes sense, because what we're going to look for is we're going to start looking for relative maxes and relative minimums. My apologies. But how do I want to put it? Let's actually just put a pin here on with the idea of relative maxes and relative minimums, and we're going to come back to this later. But I just wanted you to at least have some exposure to this language. All right, so next topic. So the next topic that we want to cover is this idea of an even or an odd function. So how do I want to... Let me see if I can strategize how to teach this to you. Let me start this way. Let me start with why you would want to know if it's an even or an odd function. Well, if you know that a function is even, it's actually really easy to graph it. If you know that a function is odd, it's actually much easier to graph it. And the reasoning is because there is some symmetry with even functions and symmetry with odd functions that I'm going to show you in a little bit. So let's just stop at that point. So that's some of the reasoning behind why you might want to know if something is an even or an odd function. But let's get to the definition. So the definition is important. So notice what this says right here. And I don't know why this trips students up a lot. Actually, that highlighting might that might not show up very well on your end. So let me do it this way. This is the definition of an even function. F of negative x is equal to f of x for all x in the domain. So let me kind of write it off to the side so we don't have to keep hunting back through those. So here's our definition. F of negative x is equal to f of x. Ready? Let me write odd function definition, and then I'll show you what you need to know to be able to do your homework and tests. So the definition for an odd function is f of negative x is equal to negative f of x. All right. So what is the game plan here? So take a look at example 2. I have part A, part B, part C. It's a simple enough question in that all you need to be able to state is whether it's even, odd, or neither. Right? If you took a guess, you have a 1 out of 3 chance of getting it right just by taking a guess. But how do we do it? So let's start with part A. So we have f of x is equal to x cubed minus 6x. Ready? Let's jump right in. So let me write the question, and I'll show you the game plan. So part A is f of x is equal to x cubed minus 6x. Okay. So let's just do some steps. Ready? Step 1. Step 1 is you are going to substitute negative x in for x. Ready? I'm going to do that right now. So I'm going to use those parentheses like I was saying earlier. and I'm just going to drag, we're going to drag and drop. We're going to place negative x inside these open parentheses. All right, now what we're going to do is we're just going to clean it up, and then we're going to look up here and answer the question. So let's go ahead and clean it up. So if you have a negative x to the power of 3, well, maybe does it make sense if you have negative 2? Let's actually make it even easier. Let's say if you have negative 1 to the power of 3, that's just negative 1 times negative 1 times negative 1, right? So a negative times a negative is a positive, and then that positive times another negative is a negative. So hopefully that helps you, because a negative x times a negative x times a negative x is going to end up being what? It's just going to end up being negative x cubed. All right, and now we have negative 6 times a negative x, so that's going to be a negative times a negative is a positive 6x. Okay, so right now your job is to understand how do I know whether this is even, odd, or neither? Okay, well, let's look at even first. Ready? So if this were even, then when you plug in negative x, you should get back out what you started with. So let me pose the question to you. So this is what you started with up here. Does that look like what you started with? No. I mean, an even function should look exactly like what you started with, and you don't. So it's not even. All right, well, let's look at odd. So the way we read odd, it states if it's an odd function, it should be the opposite signs of what you started with. So let's look right here. So the opposite signs, instead of having a positive x cubed, you should have a negative. Instead of having a negative 6x, you should have a positive. Does that match what you have? Yes, it does. See how it's the opposite signs. A negative x instead of a positive x. And a positive 6x instead of a negative 6x. So it's the opposite signs. So we know that this meets our definition of odd. Okay, so let's jump to part B. So now it's gonna proceed the same way. We're gonna do exactly what we did here, and then once we get to this step, we're gonna see if we can figure out if it's even or odd. Ready? So this is what we start with. F of x is equal to x to the power of 4 minus 2x squared. And ready, we're just going to do exactly what we did in the previous problem. So we're going to plug in a negative x. So just plug in a negative x here and a negative x here. All right, let's pick up the pace a little bit. So negative x, a negative times a negative times a negative times a negative is a positive x to the power of 4. All right, and now what about this one? Well, negative x times negative x is positive x squared. So you end up with negative 2x squared. Okay, ready? We're going back up here. So if it's an even function, when you plug in a negative x, you should get back out what you started with. So let's take, this is what we started with. We plugged in a negative x. Did we get back out what we started with? Yeah, we did. Let's see how it looks exactly the same. So that tells me it's an even function. All right, you should try h and see what happens. I'm going to go ahead and get started on h. Just writing it, but you should pause the video for just a second and try it and see how you do. All right, so is it even, odd, or neither? I don't know. Let's plug in a negative x. So we'll do that now. Plug in a negative x, plug in a negative x. Okay. So negative x squared, that's going to give me a positive x squared. And then 2 times a negative x is going to be minus 2x. And then you have your plus 1. All right. Let's take a look at our definitions. So if it were even, we should get back out what we started with. So this is what we started with. Does that match with what we started with? No. We had a positive x squared, but this is a negative 2x. This is a positive 2x. So no, it's not even. All right, well, if it's odd, if it's an odd function, it should be the opposite signs of what we started with. So an odd function would mean that this becomes negative, this becomes negative, and this becomes negative. Did that happen? No. So it's not even, it's not odd, so it's neither. All right. So that'll conclude this this first part A of this section. I will see you guys in part B.